Hi, my name's Arik, and my partner's name is Josh, and we're doing our research on the PGA Tour golf data. Josh and I are both golfers at USD, and we wanted to see how stats related to golf. And so this is why we were interested in the golf data, and maybe we could shave off a few strokes as well. And we felt like our research would be easier and more fun if we did something that we were familiar about. So then our question was, what aspects of a golf game constitute a lower score? And golf is a sport where there are so many skills required to be good. For all golfers of all levels, we decided to analyze data from each part of the golf game to find which areas constitute the best scores. After gathering data and plotting them on several graphs, the results show that all our variables have a negative correlation to average score. As the average drive, fairways hit, and greens hit increase, the average score decreases. This negative relationship is actually a good thing, as lower scores is the goal in golf. So we got our data from Pga, which was originally from the PGA Tour website, and the data is for the PGA Tour in the 2018 season, which includes all our variables. Our variables, like average score, is our dependent variable, and average distance, fairway percentage, greens in regulation, and tournament wins are independent variables. The target population for this data are golfers and sports analysts. We have collected 1,678 players in this sample, and we believe this data addresses our main question because it analyzes every part of the golf game and how it influences the average score for each golfer. So this is the data plots that we got in figure 1. This plot shows the residual plots for average distance. These are residual plots for fairway percentages, and some pros are more accurate than others, while some are further and shorter. For figure 3, you could see the residual plots for green in regulation, and some pros hit more greens than others, and this is given by the percentages. In figure 4, you can see the residual plots for number of wins, and this was our dummy variable in our research. For wins is 1, and like any win is 1, and no win is 0. Looking at the plots for predicted average score and actual score for average distance, you can see the blue dot is in a tighter area than the orange, and the blue dot represents the predicted value. And in figure 6, you see the plot for predicted and actual average score by fairway percentage, and again the orange dot is much wider variated than the blue ones in a tighter dispersion, which also the blue dot also represented the predicted average score by fairway percentage. And then looking at figure 7, you could see that the blue dot is way inside the orange dot, and this plot represents the predicted and actual score by green in regulation. And then for figure 8, this is the dummy variable of the predicted and actual score by win. And then here you can see the orange is way more separated than the tighter blue dispersion.
When looking at the table 3, the effect of average distance, fairway percentage, tournament win, green regulation on average score. We will build a population regression model from the coefficient of y average score equals to 91.25 minus 0.386 win minus 0.026 average distance minus 0.017 fairway percentage minus 0.078 green regulation. When looking at the independent variables for coefficient, we will discover they are all negative. It helps us to understand the tournament win, average distance, fairway percentage, and green regulation will all have a negative relationship with the dependent variable average score. When we are measuring the strength of the model using R-squared and the standard error of regression methods, we will discover for R-squared method, 0.680 shows a moderate strong fit of the regression model, where 0 is lack of fit and 1 is perfect fit. When using the standard error of regression method, 0.438 shows a strong fit of the regression because the smaller it gets, the better it fits.
And looking at the analysis, at the 5% level of confidence for all these variables, the confidence interval for the wins was in an interval of negative 0.443 to negative 0.328. And we could put these in words and say that we are 95% confident that as a player win for the season, average score margin will decrease between 32.8% and 44.3%. And for the 95% level of confidence for average distance, the interval is negative 0.03 to negative 0.023. And we would say that we are 95% confident that as the average distance increases for the season, average score margin will decrease between 2.3% and 3%. The 95% level of confidence for fairways percentage is negative 0.024 to negative 0.011. And we would say that we are 95% confident that as the fairway percentage increases for the season, average score margin will decrease between 1.1% and 2.4%. Lastly, for the 95% level of confidence in greens in regulation, it was negative 0.088 to negative 0.068. And we would say that we are 95% confident that as the green in regulation increases for the season, average score margin will decrease between 6.8% and 8.8%. And we would expect to find a relationship that as the independent variable increases, the dependent variable increases. So then this supports our prediction.
Going off what Ulrich said, when looking at the p-value of table 3, by knowing the level of significance is 0.05, we will reject the hypothesis for all the independent variables p-value, since all the p-values are smaller than the level of significance. When p-values are smaller than the level of significance, these variables are statistically significant. When looking signs of sample correlation coefficient, there are same sign of the estimated regression slope coefficients. Correlation metrics suggest that the independent variables are not correlated with one another, so there's no multicollinearity problem. When we are looking at the residual plot, linearity is the property of a mathematical relationship that can be graphically represented as a straight line. For the linearity assumption, we can see the relationship between x and y are linear, where there is a negative linear relationship between the residual to average distance, fairway percentage, green regulation, and win. When we are looking at the normality of error, data should be approximately normally distributed, with a peak in the middle and the fairly symmetrical. The regression parameter estimates and their variance remain unbiased and consistent. Looking at the histogram for residuals, we can see it's not skewed and evenly distributed, so the assumption of normality has been met. When looking at the equivariance, also called homoscedasticity, it describes a situation in which the error term is the same across all values of the independent variables. All its random variable has the same finite variance. When we are examining scatter plots of residual versus the predicted y variable in this graph, we can believe the assumption is appropriate by its random funnel pattern. The last assumption is for the independent of errors. The distribution of error is random and not influenced by or correlated to the error in prior observations. When looking at all of the four graphs, the independent variables of average distance, fairway percentage, green in regulation, and the number of wins shows little or no pattern to the residuals. Based on that, we can conclude the multiple regression model is appropriate for predicting the average score for all these golfers. We believe that the model matches our prediction of a negative correlation between the independent variables and dependent variable. However, it is surprising that the fairway percentage does not have too much of an effect on the average score. One improvement we can have done for the model was that we can have add a few more independent variables in the model to see their relationship with average score. For example, one place we can expand in is putting for the Pga Tour statistics. That way, in the model, we can see their impact to the average score. Another improvement we can do is putting the statistics for different seasons to see their impact on these independent variables. That way, we can have an overall conclusion about which independent variable will affect the average score the most. For our business plan, we want to target golfers that are determined to move on to the next level. We present our findings to the golf board that more green in regulation has the most effect on better average scores. These results will spread through the golf industry. We will then advertise a golf training program that puts emphasis on hitting greens. For example, we will gather top instructors to give tips on playing smart and hitting to the center of the green. More golfers will want to be in the program because the evidence concludes that more greens in regulation lead to improved scores. Golf is a sport where there are so many skills required to be good. For golfers of all levels, we decide to analyze data from each part of the golf game to find which area constitute the best scores. After gathering data and plotting them on several graphs, the result shows that all our variables have a negative correlation to average score. As the average drive, fairway hit, and the green hit increases, the average score decreases. This negative relationship is actually a good thing, as lower score is the goal in golf. While we can assume what is best to improve golf, this data analysis project helps break the uncertainty of this by pinpoint aspect of the golf game that affects scores the most. Learning from this result can help golfers improve and shoot lower scores. Thank you.